Okay, 6 p.m. PST. Let's get started. So, excuse me. So we are supposed to discuss something very interesting tonight about implementation of the printf function. That is interesting, especially because if you recall your high-level printf function in the C, and I believe Java has also the printf function. It takes a format string, and after that, you can actually use variable number of argument onto the function. It's not a fixed number argument as in the printf function goes. We'll try to review how would you implement that, what is the underlying implementation of that function in assembly language. That's our goal tonight. So before we start, is there any question on anything for me to explain? Let me go to the discussion as well. If there is any, you can bring up things. No, there is nothing. There are some on the midterm topics, so we'll discuss it next day. Hold on to that. Okay, so since there is no question for me tonight till now, let me explain that printf implementation. I'm sharing my screen. Okay, and okay, let's say I have these following implementation. Something like very high level program, let's say. Character C equals A. I'm writing in C language, but it may be a similar thing in Java as well. Is except the string definition, they differ much. It's something like in string, we define a string like character pointer. This is a pointer variable which has been abandoned in Java language for various reasons. One of them is a complication arise due to not using pointer correctly. This is very powerful tool in C language to use pointer. Means it's basically accessing the memory directly through that variable name. But power comes with a responsibility. If you don't use it responsibly, you can go wrong severely, like including crashing the entire system. So anyway, that's a different story. But let's say this is how we define a string in C. Like I'm defining a string variable s with the initial value hello, and maybe an integer 10. And then in a program, we can use something like this, printf followed with a format string. Let's say it's called char %c and string %s number %d, and it follows with arguments, and this number of argument is variable. For here in this example, it was using like I think 3 different variables to print, followed by this %, each of this formatting string. The %c is character, %s is string, %d is decimal number, etc., etc. So it uses 3 variables. So we pass these 3 variables there, c, s, and n. And this program will ultimately print something like this. Our expectation, it will print on the display character A, comma, string hello, comma, number 10 and new line. Okay, the last one is new line. So this is our expectation that display will print. On the display we'll see this tree. The question becomes like how underlying implementation is done, especially for this function implemented for variable number of argument can be passed into it. Okay. So here, let me first explain the simple strategy to it. So one is that just assume that we maintain something like pointers. Okay, so okay, so this pointer, I should fix it here. Okay, let me put another pointer. So we scan this format string from left to right. So we start with setting a pointer right here at the first character and check if it is a special character like a %. If it is not, then print that character. So in turns, we'll print C at this point. So we scan it, scan this format string, first character, C, nothing special, move the pointer to the next character, and this is nothing special character, just print it. Then go to the next character, print it, and so on and so forth. So that way we are printing like till the char, C-H-A-R space, and now we are at a point where we get a special character called %. So at this point, we know it's something like this is a formatted string, and we need to deal with some variable at this point. We don't need to print that character directly. So what we do, if it is a %, we go to the next character of it, and we see, okay, this is a character. So this variable, the first variable, must be a character value. So pick up the value of that variable, which is A, like in this example, and print that. So here, so we will end up printing A here. And at the same point, we move the pointer to the variables to the next variable just to get it ready, and move to the next character. Now, once it comes to the next character in that loop, we'll print comma is not a special character. Then we move to the next character, which is a space, and then move to the next characters, S, then T, then R, then I, and G, like this, space. And then we come to, again, another special character, %. Then we, instead of printing that character, we move to the next character, which is S, and we know, okay, S is a string, so this variable must be of a string type. So we need to print a string which is initialized for that variable. So what we'll do at this point, we'll happily print hello onto the display. And then we move the character pointers to the next character, and also move this variable tracking pointer, let's say, to the next variable. And then we keep on scanning and printing, and ultimately we'll come to next %. So far we will be printing like hello, number, NUMBER, space, then % is a special handling, go to the next character, it is decimal. So this variable must be treated as a decimal variable, and pick up the value and print it. So that's what we'll do here. Value is 10. And then there is no other character to move on. We kind of go out of the scope for that list of variables. And next character is a special character /n, which is new line. So it will print the new line, and there it ends the function. So that's the generic approach we are going to do in this implementation. And in fact, the very low level, that's what is done. Even if you feel that the whole sentence is coming up as one single stream of string, but it's basically printed character by character. In fact, it's printed pixel by pixel. That's very low level, but anyway, it's character by character is displayed on the screen. But it is so super fast that it appears to be printed like in one shot, basically. Question at this point.
Yeah, Professor.
Sure.
Yeah, so let me just like recap a little bit, and then I'll select to see if I'm so there's two different like pointers, right? So there's two different pointer like variables, and they're pointing to one is pointing to the characters in the given string, and like defined by the quotes, right? And then the other one is just the variables, right?
Other ones just variable. Yes.
Okay, so what exactly is the like architecture system that's controlling the, I guess, like keeping track and controlling the pointers? I guess it's the memory, because it has to access the memory, right? If it's a pointer, it means it's pointing to like the address, right? Like the memory address.
Exactly.
S-
Exactly. So basically, let me explain that. Actually, what your question pointing to is the inner explanation of how we are going to implement this in the assembly, in the low level. So maybe going forward, once you explain that, maybe your question will be answered. Okay.
Okay, okay, yeah.
Let me know if he still doesn't answer to your question, then we can address that.
Yeah, okay.
Okay. All right. Now, let's say we are trying to implement it in generally in this in the in terms of low level programming, right? So we all know that these all these variables, right? High level variables, string or character or value, or even this is the in place string, right? This is a string. This must be residing in a memory. So in the memory, we will have this counterpart of all this stuff, right? So for example, you'll have, let's draw that out. So in the memory, you will have, let's say, let's start with the integer variable n equals 10. So that n is represented within the memory with some values in it. So it is a decimal, like which is a 32-bit number. So 4 address spaces will be occupied for this memory. Okay, so let's draw them. Okay, and let's assume this one started with address, maybe, let's see, 10010000. So this address. And then we know that this is a 4-byte number. Let's keep on copying it. Duplicate, duplicate, and then duplicate, and finally it will be A. So this content is basically your variable n. Okay, and then let's say we place the string hello, right? String hello. So it will start from the next address. So it will be like what? This will be 4. This will be 4. 1004. Okay, and it will use the ASCII code of HELLO. So ASCII code of H would be, let me see, 68, and then it will be duplicate. This will be 65 HE. Okay, and then it will be 6C. L is 6C. LL. So these are all placed in the memory. Okay, LL. O is 6F. LO. And then don't forget the null character termination. Oops. How do I undo? Control Z. Duplicate. Null character. 0, 0, 0. So this entire part is your S, variable S. And then we place the character variable. That's a short one, only one, duplicate. It says it's A is 61 in hex, the ASCII code. So 61 will be stored here, and it will be from an address 100A. Okay, so this is what these variables are stored in a memory. So this is, let's note it down. This is your A. Sorry, not A, C. This is C. Now, also remember, this string is also placed in the memory. I'm not showing it, it will be too much to show that inside the memory, but assume it is starting from the very next address. Very next address would become like your B100100B. From the very next address, let's say that string format is being done. So this is like C, H, A, R, etc., etc. So entire format string is starting from the address this guy. All right. Now, the approach to put variable argument onto a function would be something like following. So you all know that we have the stack memory. Okay, we have the stack memory. So we will use that. So let's say your stack pointer, stack memory is starting here at the upward position somewhere. So what we'll do, we will push the values corresponding to these variables into the stack. So this is my stack. This is my $SP pointing to that memory location. We'll still keep on pushing it, but we'll keep pushing it in a reverse order. So we'll first push the N value for the N, then S, then C. So what will be ultimately pushing on the stack would be the value 10. Okay, so the entire of this thing. So 0, so we are pushing this entire part onto the stack. Stack pointer is coming down. So there goes your N. So you have pushed the N onto the stack. This is N. And then comes the S. Now, what is S? S is not hello. S is a address of this variable. Like if it is a character pointer, it's an address type. Okay. The string is always an address. So what we need to push there is the value of this address, which is we'll push this thing. Let's duplicate. It will be 04 duplicate 00 to 16. Okay, duplicate 01 10. So this entire 4 byte will be pushed into the stack, which belongs to, which represents the variable S, which is an address, 10010004. This entire thing is an address, which is pointing to the start of the string till it hits a null character. Now, the next one, come to the C, which is 1 byte. We just push the 1 byte there. We have like, our push is like more like a 4 byte push. So it will be like anyway, we'll store 4 bytes there. Duplicate. Okay, so it will be 61 followed by duplicate 00 0 0 0 0. Okay, so this entire thing is your C, value of C. And after that, your frame of the printf statement. So this is a frame of printf call. So your stack pointer is moved here and your frame pointer is at this point. So our strategy, what we'll do, we will use the frame pointer as my base register and access these variables. This one, and this one. So if I keep an index, let's say just a conceptual index I, then it will be like, let's say it is starting with a 0, then general formula of the memory address to access within the stack parts for each of the variable would be $fp plus I multiplied by 4. So if now see, if the I is 0, this value is 0, then I'm accessing from the frame pointer. Is it I plus 1 4? So it's access above. Okay, from that. I think this is okay. This is okay. We'll see. Then if it is 1, then it is frame pointer plus 4. Okay. And then if it is 2, the next one, it is frame pointer plus 8. So with using the frame pointer, we are going to access this part of the stack as a variable. So main point is that caller need to push these variable values onto the stack, then call the printf with pointer to or address to the formatting string. And then inside, we will start to read character by character, okay? And then do special action if it is a percent. If not, we just keep on printing the character on the display. And if it is a special character percent, then we go to the next character to see what kind of format it is. Is it a character variable or stuff like that? And then use the frame pointer to access that variable pushed into the stack, retrieve the value, and print onto the screen. With that, let me show you what's the program would look like, printf. So first of all, look at this. Here is the string I'm trying to print. Let me explain. Format string, format, the label format 1 is a format, my format string, which is printing my string is %s. So let me just, this is not right. Okay, this is okay. %s and integer is %d. Okay. And I want to print in the integer and label a variable named int a, which is a label in the assembly program, which is a word of hex value 10. And this s, I want to print this test string underscore b, str underscore b. So that's a label as well, which is ASCII easy test printf within quotation. So I have two variables here to push down onto the memory. So you see what I am pushing down is load word. I'm loading word of the integer value, which is the last argument. So it's going first and then it's going with the %s. So I'm loading the value of from the integer a, that memory, and push it onto the stack. Then I am loading the string, like it is a load address. Remember, this is a load address. So it will be T0 will be address of the label strb. So whatever that strb address is, like we can see that. So it will, strb would be like this, 10010028. So that will be ultimately pushed onto my stack. Then I load the A0 argument register of the printf function with the format load address of format 1. What would be that? Format 1 is loaded at 10010000. That address that will be loaded into the A0 register, and then it goes into the printf. Before we go into the printf, just remember that since the caller is pushing things into the stack, it is caller duty to pop things out of the stack. Otherwise, it will become like residual memory in the stack. It is not accessible, and so on and so forth. So, so make sure that we need to do it in using the printf. Now, any questions so far? Okay, now let's see. Hey,
Actually,
yes,
yeah.
yeah.
On your whiteboard, I think it was, there was one or two things I was a little confused about.
Sure.
Can I look at that?
Yeah.
Okay. Let me see. Oh yeah. Just for clarity, really, why on the static memory part, why do you have it going from N to C from bottom up instead of maybe CSN? Because it was written CSN in the printf function or call.
Oh, I just followed some direction. Notice,
Uh,
yeah, if you followed
so
this direction, yeah, you probably would end up C first and this one and this one.
so it doesn't really matter,
How to
or
deal with that alignment in this situation? So I went with the number first, and then everything is like can start at any address.
okay. So basically, that's just something you can pick and choose, right? Or
Uh, for example, right, if you want to be very strict, how the compiler, it all depends how this compiler translates into the assembler code. If they start creating in the same order, the label, data label, like this one, like if they start creating on variable C label first and then S, then N, then it would be order different, C, S, and N. So let's
uh-huh.
assume, like for this example, your assembler, compiler started with something like this, where n is dot word 10, and then where s is dot ASCII z hello, and where c is dot char or dot byte 61, something like that. It really depending on your compiler, what order it will generate these labels onto the assembly program.
Okay. So is there like really a reason why it would be flipped, or was that just what you had?
No, what I'm saying, it is just for this example I'm saying.
Yeah, yeah, yeah.
I don't
I know,
know.
but like, I mean, you in the first, like the high level programming part, you wrote it down as CSN, and then in the compiler part, you wrote it down as NSC. Is it like supposed to be flipped like that, or is that just how you had it?
It depends on what type of implementation
Yeah, yeah. So
has.
you
So,
just put it like that then, right?
yeah,
Or
and it doesn't necessarily change outcome of the program, but compiler sometimes reordered this in order to compact the memory.
yeah,
Okay?
yeah.
This is a character and then string, then followed by and word alignment on this guy may leave some memory unused if these are of not, like, you remember our alignment discussion, that if this guy is
Uh-huh.
started on a odd address or not address divisible by
Yeah,
4,
yeah.
like things need to be placed apart, right?
Okay,
So
yeah.
it's always possible that compiler reordered them in order to compact the memory usage.
Yeah, yeah. I was just making sure that it's like case by
Sure,
case and not like,
that's a good question.
impulsive.
Yep. So I'm just assuming. I was like, my why I went for is basically to make sure that I don't goof up with the alignment, and the easiest to start with a number and everything is a string and character, so I don't need to deal with the alignment thing at all at that point. So
Okay,
that's fine.
that's good. Thank you.
Okay. All right. So now let's see. We set up the frame. Okay, we know what to do there, so let's not go there. Body wise, what I'm doing, I'm first of all saving the argument, the A0. Remember, A0 has the address. So here the argument address of the format string. So I'm saving that in the S0 register, and S1, I am using that as a store to store the argument index and initialize to 0. So this is my S1 is this pointer, right? We are starting with this pointer at the very beginning, let's say, beginning of the variable. And this pointer is pointing here, which is right now the A0, the address in the A0. So S1 is done there, and then I have the big loop of printf loop where I will do the scan and print character. So here what I'm doing with respect to the S0, S0 is what? It is pointing to the format string, right? With respect to that, I'm loading a byte unsigned. So loading byte unsigned really means I am loading a character ASCII code into A0 register. And then I'm testing if it is a null, b equals 0. If it is a null character, then I'm done, basically. Then I'm going to the return if it is a null character. And then where is my return? Here. Then restore the frame, jump back to the caller, etc., etc. So that's my end condition of this routine. And then what I'm checking, if it is that character is a %, jump to the print format, do something special about that. Okay. Otherwise, it is simply call a syscall. This V0, we load the V0 with syscall code 11. 11 means a print character, and do a syscall. So this syscall with the call code 11 looks for the character ASCII code in the register A0. That's why I actually saved the S0, the original pointer to the format string to the S0, and using the S0 to load character by character from that format string, so that I can use A0 in conjunction with the system call with code 11. So this will print the character. And then jump to the print last. So we skip the all special formatting part and go to the last. Then I move to the next character. So basically increasing the address stored in the S0, which is pointing to the format string, by 1. Address 1 means we are moving this pointer to here, basically. So now we jump back to the loop. So if there is no special character, we simply access the next character, testing it if it is a null character. If it is not a special character either, just simply print that character. Now, what happens if it is a %? Let's say we are printing, and ultimately we come to a %. We pick that up. So what happens now? So it will jump to the print format here. Then I increase the argument store. Oh, so that means it is I plus 1. So, or this is 1. Let me see. Let me just change it. You can start with this one. Okay. All right. So here we are increase the argument register by 1, then multiplied it by 4, just like we proposed here, and then add that value on top of FP. Okay, so add it to the FP. So T0 is ultimately FP plus that argument index multiplied by 4. And then actually I'm moving the pointer one more. We need them to access the next character. We load it. So here we are moving this guy to the next character, loading it. And then what we will get? We'll get, in this example, we'll get a S, right? We'll get this %, and then we'll scan to a S. And then what we have, we basically test upon that, what we got. We read if it is a S, go to something like print str. If it is a D, go to like print int. Then you can extend it to if it is a C, then do that. If it is a I, then do that, etc., depending on that. So in this routine, we are just simply handling 2 types of variable. One is number, like decimal, and another is a string variable. But you can extend it with this general concept. So we basically test that format character and jump to the special action we need to take for that specific type of data. So let's say now it actually hit in our format, it hit S, %S. So it will jump to the print string. Okay. And what it will do, it will then use the T0 as a base register and load that complete word into the A0. Remember, T0 is contains what? FP plus this index of the variable, which is 1 now, multiplied by 4. So it is ultimately pointing here at that. Oh, this is not the same example. Right. Okay, so it is pointing to the address of strb that is being pushed last. So this is nearer to the frame. So it is pointing there. So it loads that value into the A0 and do a system call with call code 4. Call code 4 is print string at the address stored at A0. So at this point, it will print the entire string, that is test printf string at that point. And then it will go back into the loop. Now, what if it is a format string is D, it goes to the print int, simply load word again, it's a similar code like the print string, load word that. Now use a system call code 1, which is printing an integer from that A0 register. So it will print that integer. Let's try it in action. Okay, so let's say we assembled it and let's put some breakpoint. Let's see. Okay. Here. Okay. Store, then increase. Maybe here, one breakpoint. Another would be print format, which is here. This point, and here this point. Okay. Then see. Let's see. So see, it's basically came here with one string or one character printed from my original string format string my that m is being printed, and then let's go back and do my y, then space, then s, then t. So in this way, it's basically printing character by character. So we see it. Let me put that out and continue. Now it's as a point where it is trying to process the %, like my string is space. Now it is a %. It came to that special handling and increase that that argument index, multiply that argument index with 4, store it at T0, and then add the frame pointer with that value, then move the S0, access the next character, then if it is a D, it is not, then it is going to the next testing, which is S. Now it will jump to that part of the code of print the string. Now see it's printing that string as a whole, but in that process as well, it actually printed character by character, by the way, but it's kind of very fast to see in human eye. And then let's continue. Then it went through the other characters and it came to a point, integer is, now it is processing this part. So let's see what it does. So it increased the argument index, multiplied by 4, added with frame pointer, moved the S0, the original formatter string pointer to 1, access that character, checking if it is equal to D, it is now yes, jump to that part, load that value into the A0, load the V0 for syscall code and print it. Now the value is 16. So in this way, it basically go and printed the whole string character by character, and whenever it is needed, it printed the special, like either string or values, etc. Question. Okay, then let's take 5-minute break, and after that 6:50 we'll be back. Okay, let us come back and You'll find a pop quiz there in your canvas. I'm launching the poll. Mark it yes if you are ready to enter the quiz password.
Professor, what's the pop quiz number?
4. You may need to reload your canvas page. "19 of 23, 20 of 23, said yes. I'll just wait for a couple of seconds and open up it for you. 21 of 23.
Sorry, Professor, I clicked the wrong one. I clicked the exit, so I can't vote right now.
Oh, that's okay.
Yeah, just let you know.
Okay, thank you for letting me know. Okay, let me share the password with all you. Let me see if it works. Passcode, here it go. Okay, I think time is up for most of you. Let me see how you did. Start. Okay. So here your average class score is 54%, which is really poor, worrisome. 87% high score. Well, that's okay, not good, but okay. Please keep pace with the class topics. I think you guys are falling behind on the topics. That also reflected in the last quiz number 3. Let me share the stat with you guys. Like if you see the trend here, passing rate got increased in this quiz. That's good. It was quiz 1 88%, then bumped to 77%, then went up to 88%. But B minus or better is falling down gradually. That is something to worry about as a class. 81, 74, 59. I don't know what is happening. I have two theories. One is topics are getting harder concept-wise. Secondly, you have now too many assignments from the other classes are coming up, fall onto the same time period, and you couldn't manage the time wisely. I don't know whether any one of you or two, try to explain your experience, what is going on.
The second thought is pretty apt for me.
Okay, so many classes assignments are falling, converging.
Yeah, and
yeah.
that combined with the time zone difference, it's making things terrible for me.
Yeah, that's what I also thought. Like usually for other quizzes, quiz 1 and 2, when I open up like Saturday morning near noon even, like probably 60% of you have tried at least attempt 1. But this quiz 3 I have seen like maybe like 20% had their first attempt by Saturday, almost like noontime. So that's why I thought maybe many things are going on as a group, the whole class during this time. So that's why. Anyone else wants to share your experience on this? What is going on? Okay. Anyway, so please, Chirag, you want to say something? See your name popped up. No, never mind.
Oh, like yeah, I unmuted because I was about to say something, but I mean, yeah, I mean, it's pretty much the same experience. Disregarding the time zone difference, I'm still in the same time zone as you guys, but yeah, it's I think it's a little bit of both, but primarily the second one.
Okay. Got it. Yeah, please make sure you manage your time wisely. Look at, like, please schedule your work. That soft skill is very important in life. Like not only during the college time, but when you step into the industry, you have to deal with may have to deal with multiple projects at once. Like if you are in that position, that means you are doing really good in the industry, that your managers and management are giving multiple projects onto you and you can manage them well time wise. So please do practice that soft skill, that handling upfront with your schedule. Given that I believe most of the classes have upfront schedule for you, there is a green sheet and schedule established at the beginning of the classes, all the assignment due dates. So you know what coming up and how much effort you need to make in a week. So please do planning. That's what I'm saying. Anyway, so let's continue with that problem. I think this assignment was there is this assignment related to this program. Okay, So we have this one printf implementation. Now we want to extend it to have the escape character handling. Means what? Like you see in a formatting string, we put a special handling on the character %. But what if I want to print the character %? Like what if I want to really print my string is space a % and s and then go forward like that. Okay, so how to deal with that part? That is the question here. Now if I do this guy, you will see by the algorithm you'd expect like we print a backslash and then print a string, right? So let's try that. Let's put an escape string here. Function wise, I'm expecting at the end of the day, it will print my string is space %s. But what it does now is, oops, what happened? No. So it is still doing the same thing. It is not taking care of that slash either. It is not printing the slash either, but it is basically printing the previous, like the previous string it did. Now, first mystery is that why it is ignoring backslash. Because if you look at what it has actually compiled here or assembled here in the memory, let's look at that. This is your format string, right? Placed in the memory. If I just print as a characters, my space string is, see, there is no backslash here. It is this %s itself, right? So what is happening? Your program, whatever you're writing here, it is being parsed with the assembler. And that assembler is dropping this backslash, okay? This backslash, and it is basically treating the backslash % as a %. So in order to make it work, like really make a backslash right here at this point, we need to make this. Sorry. Backslash means really I'm putting a backslash here. I think I can drop this guy. Let's assemble it. Now you see there is a backslash coming up here. So this is the reason why we want to have a double backslash in this place instead of a single escape character. So single escape character won't work. In the testing, you will see there is a double escape character because first escape character, these two is replaced by one backslash by the assembler. And it ultimately places a backslash %s into the program. Now, if I run this, you see it is coming up as a backslash, just a normal printing, and followed by the printing of the whole string. But my target is to actually print my string is space a % character followed by a s, then go forward with this. So that is what being needed by this next assignment, which is based on exactly this program, but you need to handle the escape character. Question? Okay, if there is no more question, then we'll stop tonight. And next 2 days, we'll be discussing about the midterms. If you have any topic of choice, just put it on the discussion. And we'll keep on discussing about the midterm, different topics and everything, whatever question you have during next 2 days. All right, good night, everybody. See you on Thursday. Yes.
Before that, I had a question. When's the practice exam going to be opened up?
I think just in a few minutes, maybe. Let me see. Quizzes. Oh, no. It is on the next day, March 18 at 7:15. Yeah.
On March 18th.
Yeah.
I see. Okay. Thank you. And wait. And how are the solutions going to be revealed for that thing? Like, there's a condition it can only be viewed once.
Yeah, viewed once, I think through, let me see what I did. It says shows the correct answer immediately. Quiz result, no. Did I have that condition? Let me see. Only once after each item. Let's see, correct answer. Yeah, once after each attempt. Okay. You have one attempt. So basically, after the quiz, I believe you get a score, right? And then on the same page, like it will come immediately with the answer. But if you go back, if you close that session, then you won't be able to see the answer anymore.
I see. Okay.
Yeah.
Thank you.
Yeah, this is to make sure that you guys take this mock exam like after really you prepare and you're ready for the exam, not like lightheartedly you go and click and just do something. Like if you are really prepared to actually go and attend the exam, ready to review the answer, then only you go and do that. Okay, so that's basically my target is.
I see. And then after attempting the exam, can we practice some of the questions in group discussions, like on
Oh
our
yeah,
own?
yeah, yeah. Group discussion. Group is for that purpose, right? You can.
Okay. So previous quiz questions and all, it's fine
Yes,
if we
of
discuss them.
course. Yeah.
I see. Thank you.
Okay. All right. Okay. Good night, everybody.